that, we know that the combination of the three of them drove 50 miles to work. So I would just say x plus y plus z had to be 50. Sally drives twice as far as Roy. So Sally, calling y, is 2x. Yeah, twice as much as Roy. So y is 2x. And then the last one, it says that Jeff drives 10 miles further than Sally. So z was Sally plus 10. Now, there's a couple of ways you can go about doing this problem. One of the ways that you can do this is that you can move all your variables around and set it up to have a 3x3 matrix. Or if you start to see this a little bit, there's a lot of substitution you can do. And me, I would just jump right for the substitution. Since I know that y is 2x, I can substitute that there. So I know that so far I'd have x plus 2x plus, well, z is y plus 10, but what's y? 2x. By doing it that method, you're able to go ahead and do a ton of substitutions without a big deal. So you have x, 2x, 2x, and 10 is 50, so that's 5x is 40. First person goes 8 miles. Sally goes 16. And Jeff goes 26. It's real quick. Hi. We were worried you were going to not really. I was so worried. Okay. And that's where we go on that. Okay? Remember, when you have something like that, sometimes it's easier just to go with direct substitution. If you did try to do it another way, it would have been, you'd have your x plus y plus z is 50, negative 2x plus y plus 0z is 0. You see how you're making the full 3x3 this way? It's just not as clean. It works, it's just gross. 32 of the parking spaces, you can kind of do the exact same thing, but it's a little bit trickier with one of the steps that are thrown in there. So in this one, you have motorcycles, cars, and vans, which means we have to define our variables. So we have motorcycles. Like a motorcycle. Really, really gross.
It's disgusting.
We have cars.
Oh no. That's a oh, that is a car.
Man, why are you judging? What's with the judgment zone? It's a non-judgment zone here, okay?
Well, in this zone.
Well, get out of my zone then. And then the vans.
Alright.
Oh god. It's like a box on wheels.
Is the 18 van? What? It's a spoiler. It's the spoiler. The 18 van had a spoiler. And like lightning bolts on the side. Actually, it wasn't lightning bolts. It was like a stripe, wasn't it? It was a red. Was it? Yeah, it was red. So we got to do that. There it is. So then you have X, Y, and Z. Okay. How many total parking spots were there for motorcycles, cars, and vans? 180. So the combination of those three have to add up to equal 180. After that, there are there are 5 more spaces for vans than motorcycles. So vans equal motorcycles plus 5. All right. And then the last part, it says there are 3 times as many car spaces as van and motorcycle spaces combined. And this is where you got to be careful. If I have, let's say there are 4 vans and 3 motorcycles. How many total motorcycles and vans are there? 7. How many car spots would there have to be? 21. So what you're doing here is you have to think through how you would write that out algebraically. So I would say it's 3 times the quantity x plus z equals cars. Okay? All right. And then did you create?
Yeah.
Yep, absolutely. What I'm thinking of here is because it says 3 times as many as the combination, I'm putting that together in terms of the addition first, just like we did. If there were 4 vans and 3 motorcycles, we added those together prior to multiplying. Yes, sir. V plus x equals by your case here is saying that 7 would have to equal 3 times as many car spots. So 7, if there were 2 car spots, there would be 6. So what you have to be careful with there is what are you multiplying? There's 3 times as many motorcycle plus vans to equal cars. All right, it's a little weird as you go through it, so I wanted to make sure we explain that. Now, once again, there's a couple of different ways you can go about doing this. Some people have distributed at 3. You get a 3x plus 3z is y. That's perfectly fine. In my head, I start seeing this again very similar to the one we just did. There's a ton of substitutions here. Notice how we have x plus y plus z is 180. The next equation says z is x plus 5. So I know that I can do and substitute into here and have an x plus 5. I also know that I have a z in the next step that I can also replace it with x plus 5. Everybody see that? It's kind of the same basic principle where I'm going to utilize one equation within the other 2 to get one giant substitution problem. So if we do this correctly, we get x plus, well, y will be 3 times the quantity x plus 5 plus x plus 5. All I'm doing is I'm taking each specific value like we knew and putting them together. Okay? Now, your step was a little bit cleaner up front by distributing 3. You wouldn't have as much messiness as I have right now. Okay? So here I get a 2x plus 5. When I distribute my 3, I'm going to get x plus 6x plus the 15 plus an x plus a 5 is 180. If you combine all your like terms correctly at this point, you wind up with some relatively clean numbers. We get, 8x and 20. Okay. I subtract out 20, I get 160. What's 160 divided by 8? 180. So that means I have 20 motorcycle spots. So if I have 20 motorcycle spots, and then that means I have 25 vans, which means then 25 vans, these 2 added together is 45. 135, very good. The sum of motorcycles and vans are supplementary to the number of cars. That's pretty cool to put into a problem.
Oh no.
Oh, okay.
Please don't. That's why I
That's the question. Okay. You went a little weird on that. You all right? On the other side, the last 2 should have been relatively simple. Honestly, the biggest mistake that most people do, especially with the top one, a lot of decimals. You get really lost really quick in your handwriting if you don't write neatly. You have to make sure you write neatly with these problems. Remember I told you that just find the cost of each individual piece. And then 3x. Okay. So you've got your three sets of, you've got your garland for x, wreaths for y, and poinsettias or poinsettias, however you want to pronounce it, for z. And then you have a system of equations. What I did first hour with this one is that I recognized that the very top equation there, notice how they're all even? What I did right away is that I rewrote that top equation on the bottom by taking out the scalar multiple of 2. So I have an x plus 2y plus z. Half of 4950 was 2875. 2475. Yeah, 24. Okay. By doing it that way, to me, I only have to then multiply one equation to scale things out, to linear combine things out. All right. By taking out a scalar, it seems in my mind always easier to go that route. Do you have to do that method? Absolutely not. It's just the way that I like doing it, and it's my way is weird sometimes, and as you guys may or may not have figured that out. Next thing is to decide which variable you want to get rid of first. You want to get rid of z's, x's. Why? Why would you want to get rid of y's now? Because then you have to do a scalar for two of them. If I get rid of x or z, I only have to multiply one equation. Okay. See what I'm saying by that? You can no, I know. The 2y was there too, but then I'd have to, if I get rid of the y, the other one I have to do a scalar for two of them. It's less work. I'm trying to find the easy way out. Why? It's not tough. It's one of those things. Okay. So if I get rid of the top one, I'm going to multiply that third equation by 3. So I have 3x, 6y, 3z, and whatever 3 times 2475 is. 74 and a quarter. Guys, come on. There's my subtraction. X's are gone. I get 4y minus 1 z. Oops. 74, 25, 57, 75. I get 1650. I don't know if anybody did this method or not. Same idea. We just eliminated with the x value in the 5775. We do the same thing with the second equation. Get rid of the x's again. I'm going to multiply that bottom equation by 3. Just shrink this a little bit here. So if I multiply all that by 3 again, I get the same values. So we have 3x, 6y, and then I've got this equation to work with. Subtracting through 3y, 2z, 3575. Okay. In this case here, I would probably just go substitution, or I could double. If I double the y, it's not that bad. Ladies and gentlemen, way too much fun here. Right. You've got your two equations. You've got y, 4y negative z. Maybe just double that one. Or know that they're equal. 4y minus 1650 is z. You can do that way if you want. So 3y plus 2 times. You're not dumb. You made a dumb mistake. Distributing and combining. That was good. 3575 subtract 33.
That's terrible.
Dude, why is it quarter? Nope. You do something. Well, I didn't know. Oh, I subtracted. I didn't add. Sorry. I subtracted the 33 instead of adding. So 35, 75 plus the 33 divided by 11, 625.
For y?
Yes. Okay. I mean y at 6 1/4. If y is 6 1/4, I get z is 850. And then I take those values back up, x, y, and z with these guys. Has to be 24, 75. So I put those together. X plus 2 times 625 plus 850. So 2475, subtract 850, subtract 1250. I'm getting 375. So let's see. Bless you. Here, which one came first? Garland was 3 1/4, or 375, excuse me. Wreaths were then 6 1/4, and then last but not least, your poinsettias were 850. Those are really big poinsettias or very small wreaths. Because usually wreaths are more expensive. I don't know, I bet you and it's usually when you have the corners and you think you know how to do that in your head. So good your head. Because you fight in one side of your head, didn't you? Then the last one, ladies and gentlemen, the last one on here. I'll just probably just set this one up. This one was really easy. You had 3 things you were buying. You had craft paper, markers, and glue sticks. And then you had 3 people spending money. So I called paper X, markers Y, and glue sticks Z. Combination of the first three for Jesse, he spent $24.40, and he bought 3 papers, 4 markers, 5 glue sticks, and a partridge in a pear tree.
You're a real person starting.
Apparently so. Maria spent $30.40, so we know the next person spent. And then she had 6 paper, 5 markers, 2 glue sticks. And then Charles, what's up?
Does it matter that for the first one it said before taxes and then all the others it doesn't mention?
It's implied. Yeah, because how do you know what they pay for tax? What town are they in? What municipality? All that stuff. Everybody has different tax rates. And certain values of tax rates are different upon certain goods. School supplies depends. Did they buy it when it was a tax-free time, or was it a lower tax thing? Some counties have that. So.
I just didn't know.
Yeah, see that? That's confusing.
Yeah. I'm just trying to show like you don't know. It's not implied. And then last one, he had 3 papers, 2 markers, and a glue stick for the cheapskate of $13.40. Right off the bat, in my head, I'm looking at this and I'm thinking I'm going to use that third equation to get rid of z in the other 2. The reason why I'm saying that is because z has a coefficient of 1. It's easier to multiply it out. That means I have less multiplying to do. I don't have to multiply 2 equations, I just have to multiply 1 of them. So it's half the chance of me screwing something up. Doesn't mean that I won't, but.
So I don't use the top.
Nope. You can use whichever one you want. It doesn't matter. What I'm saying here is, if I see this one being the only one value,
I get why you would use it. I get it.
and then you go through all that.
What are your answers?
I don't remember.
I didn't know you had one.
I will take this third equation, and I'm going to multiply it by 5. I get 15x, 10y, 5z, 00767, I think. Is that right? Help me out. Okay. Say 3x, 4y, 5z. Subtract all those through. We have a 12x, 6y, 60, 4260.
Yeah.
Help me here. 4260.
Yes, it is. I told you about it. Right?
Okay. Do I do the same thing? Once again, I'm going to take that that third equation. Now this time I'm going to get rid of the z in the second. Oh, look what happens! Yay! We get rid of x's and z's. So when I subtract all these out, I get negative 1y is 2680 minus 30. That means my markers are $3.60. Yes, sir.
On the other one,
Yeah.
shouldn't it be times 5 to get 5z? And so then it would be 3x times 5 on the bottom.
This equation, I made at the top. The reason why I made it at the top is because I knew that this number was going to be bigger. That way I was keeping it at the top. So The markers, who would have thought they were round? 360. Markers were round. Thank you, ladies and gentlemen. You only have like what? October, November, December, January, February, March. 8 more months of this fun. So y is 360. That means 12x plus 6 times 360 is 4260. X is going to be some number I don't know off the top of my head. I think it was cheap. $1.75. So you have $1.75, 360. So 1340 minus 3 times $1.75 minus 2 times 360. I had glue sticks at a whopping 95 cents. That is expensive for glue sticks. All right.
I feel like I have one.
No, that's I tried to stick my foot over here, so it lands my foot. So, last throw. What's your expect? Ladies and gentlemen, come on. What we've done here in chapter 3 is basically kind of the same style problem over and over and over again. We started these things out with graphing. Anytime. We started these things out by graphing our systems of equations to find out the intersections. And we found out right away that that kind of stunk. It was not efficient at all. After we did that, we realized that using algebra was a whole lot easier. Doesn't scroll. So when you had your algebraic systems, it was just a matter of solving for x and y, using substitution, elimination, linear combination, something along those lines. Now, what we were doing here with that was we made decisions. We solved for x and y, we had ordered pairs. Sometimes it didn't work cleanly. Sometimes you had no solution, or sometimes you had infinite solutions. What was the difference? I know she's not copying your work, right? Right. Close up your stuff so she doesn't copy it up. Otherwise I'll start emailing your teachers. Okay. What's the difference between the two? Yes, ma'am. It doesn't necessarily have to be vertical. What was the difference with the algebra stuff? They're the same line, but algebraically, what does it look like?
When you can rearrange these equations to get the line.
It's the same equation.
Yeah.
Or if you solved it out, you got a true statement like 0 equals 0, or 6 equals 6. Something along those lines. You get a true statement, you have infinite solutions. It was the same line, like you were saying, that you can manipulate the equation to make it work the same. When it was if it was no solution, what they have in common?
They have the same slope.
They had the same slopes, but they didn't necessarily have the same intercept.
One or more of the equations are parallel.
Right. What happens with those is, if you guys remember, most of our equations were always written out in what we call standard form. One of the things that you could have done rather quickly looking at these things with the standard form was find the slope. Do you remember how we found the slope quickly on the standard form? Very good. Opposite of A over B was one way to look at it to see what your slopes were right away. And then obviously if your equals value was different, then you knew it just would have been no solution. Also, what would happen is your x's and y's would eliminate. You get 0 equal 6. That's a false statement, which meant you had no solution. We had that from time to time with the 2x2s. I don't think we really came across most of that with the 3x3s. So after you did those, then we started talking about graphing inequalities, which was our shading thing. We got shaded bounded regions. We were looking for intersections and things like that. When we did that, That led us to be able to get into constraints. Constraints gave you bounded regions. Within those bounded regions, you were able to find maximum and or minimum values depending on what the questions were asking you. You had to find where certain lines ran into each other to figure out where the what is it called? Not bounded. It's the points that they changed direction. The points of inflection. I forgot what the word was called. Where they changed direction upon the graphs to allow you to figure out what your test points were. After you did that, then it turned in. Remember, we did not do 3, 5, so don't worry about looking at any of this graph and stuff. After we did those max minimum ones like that, it jumped right into linear programming. Linear programming, which we spent a week on, allowed us to find maximum and minimum values within a constraint problem. You were given a specific task to achieve. For example, if I'm looking at this one here, we're talking about appliances. Why not? Work. You are ordering upright chest, or you're operating chest and upright freezers. A chest freezer costs $250 and it gives you a $40 profit. An upright freezer costs $400 and it gives you a $60 profit. Based on your previous sales records, you know that you expect to sell at least 100 total freezers. Your total profit must be at least $4,800. Find the least number of each type of freezers you should order to minimize your costs. What's the objective?
To minimize costs.
Minimize costs, yeah. Minimize costs. So right off the bat, it tells you to minimize costs. Well, you had two variables. You had chest freezers, we'll call X because it came first, and then upright freezers, we'll call Y. All right? What was you want to minimize costs. What's the cost of the chest freezer? $250. So your $250 times chest freezer plus how much is the cost on the upright? $400. There's your objective. What were the two things it talked about now? It talked about like how many you have to have on hand
And then how much you have to make.
and how much you have to make. Good. So you've got your two values then of your constraints. You have to have a minimum units to sell. The least amount you can sell is 100 of them. So some combination of both of these has to be at least 100. Greater than or equal to. Very good. That is a greater than or equal to problem because the 100 is the bottom amount. Goes along the same lines. It talks about the least amount of money you're going to spend as far as your cost of ordering them was $4,800, I believe. So that meant that the least amount you can spend on your inventory was $4,800. And I think it said that it costs, I'm sorry, not the inventory, that's the profit. I spoke incorrectly. I'm so used to doing inventory problems. This one is the least profit. So the smallest amount of profit you want to get is $4,800. Now, how much profit you get on the chest freezer? 40. And then how much on the upright? 60. So that gives you your two equations. Is this going to be first quadrant? Do you have to write that out? So here you can make a decision. If you look at that 40, 60, 4,800, aren't those all kind of multiples of 20? If you wanted to, could you simplify that out? It's fine. But if you've got a calculator and you're trying to do your intercepts, you don't really need to, do you? It's just one of those things. If it's cleaner for you, that's fine. So as you look at this one to graph it through, we know it's first quadrant problem because we can't have negative freezers. The freezers can have negative degrees, though. So looking at my intercepts, the first one will have intercepts at 100 on both of them. The second one has intercepts at, 120, and the other one is at 80, I believe. So I'm going to plot the largest one first. The largest intercept was at 120. That was on the X. That one had an 80 on the Y. With those two, was it an inward shade or an outward shade? Outward. Outward, because you want 0 plus 0 is not smaller than 4800, so it's got to move out. So we're moving outward here. The other graph had them at 100 each. What's that?
One's greater than not going up.
Could be different quadrants. Again, this is moving outward. So they intersect there. But one of the things that I was noticing on some of your skill checks, you guys tend to forget where your boundaries go. Once you get your intersection, you know where your lines are going out. You know that the red one has to go here. What I want you to do is take a second and just kind of overdraw where the overlap occurs. Where does the overlap happen? The overlap is going to happen here at 0, 100, whatever this point is, and at 120, 0. So we have to figure out where this one occurs. So if I do that and I just multiply that top equation by 40, subtract it from the bottom, I get 20y is 800. What is that? 40? Very good. So my y value is 40, my x value is 60. So I test that one as well. I did this one earlier if I haven't saved my calculator still. Bless you if I didn't drop a break in. Scrolling. So the first one here gives me 40,000. This one gives me 31,000, and this one gives me 42,000. Which one of those gives me the minimum cost? 40y. How to get 40y? I took this one here. I multiplied it by 40. I subtracted from the bottom equation. Instead of doing substitution, I just thought it would do something different. I'd say that x is 100 minus y, and then I'm distributing it here. You get the same result. What would be your x? 60. Yeah, if you do it right, you still get the same ordered pair. All right. So this gives me the minimum. Be careful. Some of you guys, and I let it slide a little bit on that last skill check with those. If it asks you how many of each type, you just don't write 60-40, because I don't know what 60-40 is. Some of you guys might have called your x values your upright freezers, and you would have been flip-flopping wrong. So let's label it. How many of each type do you need? You need 60 chest freezers and 40 upright freezers. And that's what I'm going to do for that. Remember how you read the distinction between a linear programming problem versus just a standard 3-variable one like we were doing yesterday. The linear programming states minimum or maximum. It'll ask you something specific along those lines. And that's really the easiest thing to go for. Right? Other than that, I posted the review from the book. That's just the 6 pages or whatever's on there. Just use Slater if you need to look up answers. I know it's weird, but yeah, we should be good to go. Monday we'll start with quadratics, and that Sure. That's about a week or so still out from that. Yeah. Because I have to show you something before we do the songs. If you ask your sister, she might ask her if she remembers the cartoon. Yeah, there's a cartoon that I show that's just amazing. It's one of the greatest things I've ever seen on TV. Watch your handwriting with these things, guys. so many of you guys write too fast and you mess something up? What other question do you have or a style that you wanted me to redo? Tons of